Hi everyone, welcome back to the series on networking. In this particular video, we're going to be taking a look at a very important component of the networking field. This is the IP addressing video. In this particular video, you will be introduced to IP addressing, how it makes it possible for you to communicate to other devices on your network or on the internet. In this particular video, we'll be taking a look at three different aspects. Number one, the addressing itself. We'll take a look at binary and decimal numbering systems, which is a very important aspect of the addresses, because the addresses that you write it in the decimal format, but the computer understands those addresses in the binary numbering system. So you need to know how, when you write a particular number in the decimal format, is converted over to binary and vice versa. We'll also take a look at another component which probably is new to you guys, which is the subnet mask. Every IP address that you have has a component known as a subnet mask, which identifies a certain aspect of the address within the address, and you'll get a more clear idea as we go through the video. So first of all, the IP addressing overview. What does it do? You've been introduced to it in the previous videos as well, in the sense that you guys at this point should understand that the protocol, the language that is spoken by the internet or in general in networks today, is this protocol known as the IP protocol, or the internet protocol. Now, in the internet protocol, you do have to identify every device uniquely within your network, and that identification for each and every individual device on the network, whether it's locally on your local network or globally, is this address known as the IP address. The IP address, when you write it, it is a number that is written in the normal decimal format that we use in our day-to-day life. So you'll have a number something like this: 50.150.91.87, something like that. It's a 4-digit number which is separated by dots between the 4 digits. Now, when you write it, when you look at it, you see this as a number that has 4 digits or decimals that we use in our day-to-day lives, but you need to understand that the computer processes this number as binary. Binary is basically a combination of zeros and ones that make up the binary numbering system. So this digit that you see over here, that 50 that you see over here, this digit, this number that you see, is broken down into 8 bits. So the actual computer processes it in a block of 8 bits, also known as a byte. And from the perspective of the IP addressing, this is 8 bits, which is also known as an octet. 8 bits. So whenever you see the number, although you see a decimal number, it is actually processes a combination of 8 bits, and you have 4 of those 8-bit numbers in an IP address. So every IP address is made up of 32 bits, 8 bits, dot, 8 bits, dot, 8 bits, dot, 8 bits. Because it's in binary, the number that you get over here is based on this binary number, which is a total of 8 bits. And I'll show you what those combinations, what those range of numbers that you can have in each one of those octets over here. So from this point on, I'm going to be referring to this block, which is separating the different digits to each other, as an octet. The octets are separated from each other by these dots in the middle. So in an IPv4 address, you have 4 octets separated by 3 dots in the middle. All right. What is the function of the IP address? Is to uniquely identify the device for the internet protocol on the internet or any network that you have. All right. So with that in mind, let's take a look at this over here. The IP addressing overview. Some of this you know already, as this the first bullet you should be comfortable with. Most of the devices on the internet communicate to each other using a protocol called the IP protocol. You guys know that. Most of the internet is running. Now, this is new information. It is running a version of the protocol which is called the version 4 of the protocol. So sometimes you'll see IPv4 being mentioned instead of IP. IPv4 is equivalent to what most of the time when you refer to IP, it is IPv4, the current version or the more dominant version of IP on the internet. Although having said that, because there's more and more devices connecting to the internet, there is another version of IP that has come about and is being used on the internet in conjunction with IPv4, but not to the same extent that IPv4 is. That version of IP is IP version 6. But anytime you refer to IP version 6, it is going to be referred to as IPv6, whereas IPv4 and IP are interchangeable. So when you have an IP address which uniquely identifies the device on the internet, which we again have established, so these two things we've done already, this address can be sometimes be referred to as IP address or IPv4 address. Either way, it is the same component that we're talking about. So they can be used interchangeably. Now we also in this particular video, we also established that the IP address is a 32-bit number. So if you look at this number over here, which is 199.87.20.5, this number actually, when the computer processes it, although we look at it as a decimal number, is processing it in the binary numbering system. In the binary numbering system, you have two digits, a 0 or a 1, bits as they're called. Now, each octet over here represents 8 bits separated by a dot, as I explained to you in a while back, just 2 minutes ago. So same thing over here, 8 bits, 8 bits, 8 bits. So when you look at an IPv4 address or IP address, it is an address that is 32 bits long. But when you look at the number, that 32 bits number is broken down into 4 octets, 8 bits each. The 4 octets are separated with a dot. The total size is 32 bits, 4 octets. Now, to make you understand this a little better, I need you guys to be good at the IP, you should be good at the decimal to binary conversion. And that's what the next part of this video will cover over here. So let's go ahead and take a look at that over here. Binary to decimal numbering system. Again, as I said, I'm going to do the binary to decimal numbering system from the perspective of the IPv4 address or the IP address. As we talked about, there are 8 bits in an octet. So what I need you guys to do is take a look at these 8 bits and what different combination of decimal numbers can I get. Now, if it's 8 bits, the conversion that you need to do, and this table is the one that I'm going to use for that conversion, but I'm going to write it down for you guys and I'll come back to this table once I'm done with the explanation. So in order to convert these 8 bits between decimal and binary, you need this table, which I call the magic table, to do the conversion. The magic table, to first of all create it. How do I create it? I start with the number 1 on the rightmost bit and double the number next to it. And I'm going to keep on doubling it until I get 8 numbers that I can work with. So first number is 1, double it, becomes 2. If you double 2, it becomes 4. If you double 4, it becomes 8. If you double 8, it becomes 16. If you double 16, it becomes 32. You keep on doubling until you get 8 digits over here. If you take a look at it, 1, 2, 3, 4, 5, 6, 7, and 8. You have 8 numbers over here. These are the bit values. This table over here will help you do the conversion between binary and decimal. Although I've given you an easy way of doing the decimal conversion, just for curiosity's sake, if you want to find out how did I come up with the number, when you do the conversion over here, the way I get the 1 over here is you start with the binary system, which is 2, and start with the power of 0. Anything to the power of 0 is 1, and that's why I get the 1 over here. 2 to the power of 1, anything to the power of 1 is the same digit, which is 2. 2 to the power of 2 is 2 times 2, which is 4. 2 to the power of 3, so you keep on adding as you go from right to left. 2 to the power of 3 is not 6. 2 times 2, which is 4 times 2, which is 8. 2 to the power of 4 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. Rather than doing the mathematics for this one, I've given you an easy way of depicting it. The table that I need for the conversion starts with 1, double it up until you get the 8 bits. Now, how does this table help in the conversion? Let's say I wanted to write a number, and forget about IP addresses at this point. Let's take a look at it as a general number between doing a conversion between binary and hex. How would I do the conversion? Let's pick a number over here. Let's pick a number like 150. This is in the decimal format, and I want to get the binary format of it so I understand how the computer processes it. You might say, why do I even care about it? You really don't care about how the computer processes it, but it is essential for us to know this, because when we assign these addresses there's certain calculations that you will do in a later video where this becomes essential for you to be very good at decimal to binary conversion and vice versa. So if I have 150 over here, it's not that tough to do. You take 150 and you move from left to right. Take a look at what combination of these numbers will give you 150. So the combination, there's only going to be one combination that will give you 150. So if you take a look at 150, the way I do it, I know if I want to get 150, I need a 128. Always move from left to right. That means I got 128, and if I wanted to get 150, I'm only left with 22 more to get. If I need 22 more to get, I cannot use the 64, which would put me over the 150. So I'll put a 0 over there. So any number that I want to use, I'm going to put a 1 underneath it. That's your binary equivalent of it. For 32, again, I'll put 0 because it is greater than 22. Now 16, I will use 16 because that would give me, it will get me closer to the 150. I need to do exact 150. So as soon as I use it, I subtract it from my number, I get 6. So again, 6 is greater than this guy, so put a 0 over here. 4, oh yeah, I can use 4. That leaves me with 2. So I'll use 4 and put a 1 over there. 2, I can use it. And if I use 2, I'm left with 0. The bottom line is I need to get a 0. So whatever else is a 0. So 150 in decimal is written as 10010110. I try to write it in blocks of 4, it becomes easier to write. So that 150 number in decimal is 10010110 in binary. Let's do another conversion, and then we'll take a look at another 4 comparisons in the slide as well. So before that, let's do it again over here. First thing, create my table. How do I create my table? Start from the right, start with 1, double it up, becomes 2, double it up, becomes 4, 8, 16, 32, 64, 128. This is your table, and I showed you the easy way to get that table. Now pick a number. Let's say we pick 105 as a number. How do I get 105? Again, 105, start from left to right. 105, if I put a 1 over there, would put me over the numbers. I'll put a 0. 64 is good. I'll put 64 over here, but subtract it from 105. That gives me 41 now left. 41 left over. I can use 32. If I use 32, I'm left with 9. 9, if I use 16, it would be over 9, so I'll put a 0 over here. I can use an 8. If I use an 8, the only one that's left, the number that's left is 1, and I have a 1 over here, so the rest of them can be 0. So this one represents 105 in binary. So I would write 105 equates to 0110 1001. Building blocks, guys. These are the blocks that I'm going to build the whole course on. So just remember how to do the conversion at this point, because this is going to be helpful for a later topic that we'll be covering. So 105 we've got. Let's do some other examples of doing this conversion. I'll do a conversion from the other way around as well. Give you a binary number and convert it over to a decimal number. But that's easier. Let's do the conversion of this one first. So this is the number that I have, 199. How do I convert it over? Again, using the same table. You guys take a look at it. The table was created by using 1 and doubling up all the way across from right to left. Now to use or convert the number 199, what did I do? I took 199. First digit is 128 because I'll get that. So as soon as you use 128, 199 minus 128, I will get a 71, I believe. So 71, again, I'm going to use a 64 over here. So if I use a 64, I'll subtract it. If I subtract 64 from 71, I get a 7. So 32 is too much, so put a 0. 16 is too much, put a 0. 8 is too much, put a 0. Then I have 4. Yeah, I can use 4. If I use 4, I'll use it, subtract it, I'll get a 3. So the next digit over is 2. I need to use 2. Subtract it, use 2, and I get a 1. And last one, I need a 1 to get that number. So this would be the equivalent of 199. 11000111. And that's what you guys see over here. 11000111. Another example of the same thing. Again, more examples that you do, better you get at it, and it is important that you get good at it and fluent with it. So 83 again, how would I do it? 83, I know it's going to be a 0 at the start because 83 is less than the 128. I will use a 64, and as soon as I use a 64, subtract it over there, that becomes 19. So 32 would be too much, so put a 0 over here. The next one is 16. I need a 16. If I need a 16, I'll put 1 over here, subtract 16, I get a 3. Now that I've done it a couple of times, I know 3 is 2 plus 1, and that means the other two digits are going to be zeros, 0011. So this would be your equivalent of 83. 0101 0011. So that's also done. Next one up is 20. And how do I write 20? 20, I know I'm not going to use a 128. I'm not going to use a 64 or a 32. Why? Because it's too much. I'm only needing 20. So it starts with 0, 0, 0. But 20, as soon as I say 20, 16 is included. So put a 1 over here, subtract 16, I get a 4. Now, 4 is one of the digits, so all I got to do is put a number 1 over there. The rest of the digits, 8 is a 0. 4 I'm going to turn on. The other two digits become 0, 0. That's an equivalent of 20. Take a look at it. 0, 0, 0, 1, 0, 1, 0, 0. I try to write them in blocks of 4. Becomes easier to see. Rather than saying 8 digits or 8 bits together, it's easier on the eye to see 4 bits together. Just so that you can see it better. 5, very simple. 5, again, if you take a look at it, the combination of 5 is these two bits. The rest of the bits are going to be 0. So the first 4 for sure. The fifth one as well. 6th one, which is a 4, will be 1. 2 will be 0. 1 will be that. That's 4 and 1 turned on, which gives you 5. Hopefully you are understanding, following along, and that's how I would write it. All right, and I've given you the procedure over here as well, but the video should definitely help. So this is a conversion from where? If I have a decimal number and converting it over to a binary number. Okay, the next example that I want to do over here is the other way around. I want to convert from a given a binary number, write that in the decimal format. How would I do that? In order to do that, what I'll do is I'll plug these numbers into my magic table. So let's say my magic table was empty. Let me do that for you guys over here as we're doing it. So I am going to delete these values. And I want you guys to follow along and see what I did. So if I write these values over here, I'll write them in my table. 1, 0, 1, 1. The first digit I'm writing. Then it's 0, 1, oops, 1 and 0. So if I have this, the way I come up with this 182 is basically adding any of the bit values that have been turned to 1. So once I put that in my table, I take a look at it. The ones that are turned on are 128, 32, add them up. Keep on adding all the digits that are turned on. So 128, plus 32 plus 16 plus 4 plus 2, and that would be my magic number. So 128 plus 32 plus 16, which gives me 176, plus 4, 180, plus 2, 182. Hence the number 182. All right. The next one over here is 01011100. Again, I'm going to do the same thing over here. Start with a 0, 1, 0, 1, and then I have 1, 1, 0, 0, and that number over here becomes 92. How come? I have 64 I need to add. I have 16 that I need to add. That already is 80. I have 8 that I need to add, which is 88, and I have 4 to add, which is 92. Very simple. Again, plug in the bits for the third number, which is 1, 1, 0, 0, 0, 1, 1, and 1. So that number, again, if I add the corresponding bits together, bit values together, I'll add 1 because it's turned on. Add 64, it's turned on, which is 192. Add 4, which is turned on, which is 196, 198, and 199. And the last value over here is this value over here, 0, 0, 0, 1. So far I have 16 plus 8, which is 24, 0, 26, and 127. So by putting the numbers in my magic table, I get the conversions done. All right. I've also given you an example of that over here as well. Hopefully everybody's good with that. That's a conversion between binary to decimal. So again, you might say, why am I doing this? Trust me, this will come in handy later on in the course and later videos where we'll do extensive conversions or have to have a good understanding of the binary to decimal conversion. So this is an important exercise that I want you guys to get fluent at. Put some numbers for yourself and try to do the conversion. Use this table that I gave you, starting with 1, double it up, 128. You really don't need to get into the math of 2 to the power of 0, 2 to the power of 1, but just understand that's how the table is built. So once this is done, we have an understanding of how the actual PC will process the number. So if I had a number like 182.92, that would be my IP address, format of an IP address. It would be written like that. What I'll do over here to make it even better, in this thing over here, I'm going to put a dot. And I'll bold the dot so you guys understand this is a dot in an IP address. One, two, 3 dots separating these numbers from each other. All right, so 4 numbers actually separated with the dots. So you guys have that over here as well. So we've done the conversion. The next thing that we need to take a look at in this particular video, and the last and another important thing over here, is your subnet mask. Now, whenever you look at an address, it has 2 components to it. Where is this? Over here. Now, the 2 components of an address that you have are very similar to the way you have street names in real life. Let's say you have to go to a friend's place and he gives you his street that he lives on, and on that particular street, the building he lives in. So when you look at that address, you look at the address like this. Let's give you an example. 101 Baker Street. By looking at this address, you know there's 2 components to this address. The street the building is on, and the unique address of that person on that building. So 2 components that you have, the building address and the street address that he lives on, the street and the building on it. All right. Similarly, in an IPv4 address or an IP address, there are 2 components. One component is the common network that every device, the devices are on. So all the different devices on that particular network, on that particular LAN, would have the same common network address. But to identify that particular device uniquely, that device also has to have a unique address. In terms of the terminology, the addresses, when you see an IP address, it is broken down into two different parts. The two different parts are your network address, that is the common address, which is what you would equate to your street name. So every device on that particular street will have the same street name. Similarly, all the different devices on that network will have the same network address. But on that street, each building will be uniquely identified. That address, in terms of networking, is known as the host address. So an IP address is broken down into two addresses, two components, I should say, the network component and the host component. So when you saw this address, like 199.50.20.87, this address this is an IP address or an IPv4 address, but this address has two components to it. By looking at this address by itself, I cannot tell which part of the address is the network portion and what is the subnet portion. Sorry, the host portion. So I don't know that. In this address, again, what are the two components that I need to find out? I need to find out the network address, which will tell me all the different devices that exist on my network, and I need to find out the host address. That's a building address for my device on that particular network. Okay? And that is done by using another identity, another address that is a corresponding address to your IP address. An IP address, whenever you write it down, always comes with the corresponding what is known as the subnet mask. Very, very important component. So anytime you go to assign a device an IP address, you are also going to assign it its subnet mask, which is basically defining which part of this IP address is the network address, which part of this address is the host address. It is done by using, keep it simple for right now, a number 255, which represents the network portion. The corresponding octet will be a network portion, and a 0, which corresponds to the host portion. So for example, in this 199.50.20.87, let's say the first 3 octets are representing my network address. As a network administrator, I want to define my network address as the first three octets as the network portion and the last octet as the host portion. So the street address, I want it to be 199.50.20. Okay, so how do I make sure that? The way I make sure that is by writing the subnet mask like this. If I want my octets to be a network octet, the corresponding digit in your subnet mask will be a 255. So when I write a 255, that's telling my device that the first octet in this address is the network portion. If I write another 255 over here, it tells this is also part of the network or the street. If I write another 255, that means the first 3 octets are all network portion. And for a host portion, in my subnet mask, I'll put a 0. The 0 represents the host portion. So what that basically means, in other words, all the different devices on this network connected to a network generally is connected to a switch. So all the different devices on this network will start with 199.50.20 in the first 3 octets. They have to have the same network address because they're on the same network which is connected to a switch. But their 4th octet is the one that will distinguish that device from other devices. That's the host portion. All right, so that would be anywhere from 1 through 254. I'll explain why that in a bit, but this is the octet that will define the host uniquely. But all the other devices, just like buildings on a street, will have the same common street address. This is the building address, the host address. And how does the device know that that is the case? By looking at the corresponding subnet mask. So the subnet mask goes in conjunction with the IP address to let the device know which part of the address is the network portion, which part of the address is the host portion. To take it one step further, although I write 255 over here, in reality, what is happening is the bit 1 is identifying the network portion. The bit 0 represents the host portion. The bit value 1 or 0 represents the network or the host. But you saw a number 255. The reason you saw a number 255, because in essence, when I write 255, I'm basically saying the entire octet, the bits are network bits. Because if I turn all the bits in an octet on in my subnet mask, because the 1 bit represents the network bit, it is basically going to come up with the number of 255. That is basically adding 128 plus 64, which is 192, plus 32, which is 224, plus 16, 240, plus 8, 248, plus 4, 252, plus 2, 254, plus 1, 255. All 8 bits, when they're all turned to 1, they represent the number 255. So although when you wrote, let's say 199.50.25.87, and I wrote the mask as 255, I'm basically saying the entire set, the entire octet is the network portion. Because although you see decimals, the computer sees binary. So it's a bit by bit type of thing rather than an octet by octet type of thing. Although when you look at it, it looks like it's working with the octet. Later on, you'll see the significance of it when I will borrow some parts of the octet as network and some parts as bits. So that's where it becomes significant. For right now, when you see this 1111 or you see a 255, don't see a 255, see it as 8 bits being network bits, because when I have a 255, that means all the bits are turned to 1, and 1 represents the network bits. 0 represents the host bit. So I said this is also part of the network, also part of the network. So 24 bits are part of the network. And I put a 0, you see a 0, but the computer doesn't see a 0, he sees 8 zeros. So basically saying all these 8 bits are host bits. It has to be contiguous from left to right. So whenever you start the subnet mask, as soon as you have a 0 bit, the rest of them has to be 0 bits. So another way of writing this, you can write it like 199.50.25.87, or you can write it as with the mask of 255, 255, 2550, basically saying that the first 3 octets are the network portion, and the last octet over here is the host portion. All right. Now, another way of writing the same thing, if I wanted to write the same thing, I could have written it in a different manner. What is the other way to write it? Rather than writing this long mask, I could have written it like this: 199.50.25.87, the same address, but I can put a slash and the number of bits that make the network portion, because it's always from left to right. How many bits is it? 8 bits, 8 bits, 8 bits. So total of what? 24 bits. So I could write this address like this as well. 2 different ways of doing the same thing. You can do it like this, or you can do it like that. Essentially, what the subnet mask is doing, it's basically telling the computer which part of the IP address that has been assigned to my PC is the network portion, which part of the address is the host portion. The network portion is represented by 255, which in reality is the bit value being 1. The corresponding bit on the IP address is the network portion. That's what a 255 means. And a 0 bit means it's a host. So the network bit and a host bit over here. That's what it is representing over here. So let's take a look at this over here in the slides. The IP address has 2 parts, the network and the host part. This is similar to a street address. I'm looking at a different street over here. You look at a street address of 150 Tasman Drive. It has the house number, building number, and the street number. So all the buildings on that drive will have Tasman Drive in their address with a different unique building address. Similarly, all the devices on a common network will have a common network address with a unique host address. Right? How do I determine which part of the address is the network address versus the host address? It is done by the accompanying number or value called the subnet mask value. All right? So whenever you put an address on a device, it also needs a subnet mask that would specify which part of that network is of that address is the network portion, which part of it is the host portion, which we went into detail in explaining or understanding. The next thing is an example over here. So if I have an address like 199.87.50.5, it's an address. It would have an associated mask. It cannot be without a mask. It's always associated with a mask. When you see a 255, 255, 2550, that tells you that the 255 corresponding digits, which are 199.87.50, are the network portions, and the 0 corresponding one is this guy over here is your host portion. All right? So the 255 represents the network, 0 represents the host. Now, as I said, although you see a 255 and a 0, in reality, it's what? Ones. 1 represents the network portion, 0 represents the host portion. Because the first 8 bits are the network portion, first 24 bits in reality are the network portion. I will write that in the octet. And in the octet, if the entire octet is part of the network, I would put 8 ones. And if I add them up, the bit values of the 8 bits, it would come to 255. And that's why you write 255 to represent the entire octet as a network octet. All right, that's what's explained over here. Now, I also told you the other way of identifying a network. Rather than doing the 255, 255, 2550, you can also add up the number of bits that make up the network portion. This is known as a prefix of the network or the network bits, which is basically the number of network bits. So in our example over here, we had first 8, second 8, and third 8 as the network bits. That's a total of 24. So the same address could be written as 199.87.50.5 with a long mask, this mask, or it can be written as /24. That tells the computer, the PC, or the device that the first 24 bits means the first 3 octets over here, 199.87.50 represent the network, and 5 is the unique host of that's the host address of that device. So all the different devices on my network that I'm on will have the first 3 octets like that. So /24 specifies the first 24 not bytes. Somebody's been hungry. Is representing the network bits. The first 3 octets are the network bits, so 0 represents the host portion. All right, so all I wanted to get across in this particular video in terms of the addressing is that when you see an address, you should be able to, number 1, be able to convert that from decimal into binary. Number 2, you should be able to identify by looking at the associated mask what portion of that address is the network address versus the host address. All the different devices on the same network will share the same network address, but a unique identifier, the host address. That's what I wanted to get from this video at this point. Now, I'll also talk about one more thing before we end the video, and that is the communication types and the address types. On the internet or on any IP-based network, there are 3 types of communications that you're going to have. One communication is when I want to send traffic from my device to a specified device or a specific device. So my device wants to talk to another device, a single device, a one-on-one type of communication. Specific destination. This type of communication is called a unicast communication. A unicast communication is a one-to-one or one-on-one communication. So when I want to communicate on the internet, I want to go to a specific server, I will specify the IP address of that particular server. That is a one-on-one communication. And the destination address in my packet to send that packet to a specific destination will be known as a unicast packet. Unicast means it is meant to a specific location, a specific destination. That's the first type of communication that I have, one-on-one, which is unicast. So unicast represents a one-on-one communication. This is the most common type of communication on the internet. Now the other type that you want, let's say I want to send the traffic to everyone either anywhere connected to me. So let's say I was sitting on a router which is connected to 4 different segments or 4 different networks, and I want to send traffic to all the different networks. So it's a one to all. I'm sending a communication from my router to all the different devices connected around me. So I'm going to broadcast that traffic to all my devices that are connected to me. This type of communication is known as a broadcast communication. Okay, so it's sending the traffic to all devices on this network, this network, this network, this network, any network that is connected to me. So even with that, you have 2 types of broadcasts. One is to all devices that are connected to me. So that address is a specific address. So if I want to send a all network, so all networks that are connected to me broadcast, in the destination address, I use a special address called 255.255.255.255. So this address as a destination indicates any network that is connected to me, and on that network, any device, I'm going to send this particular broadcast to. I want everybody to know about a particular transmission. I'll send it to this address. Now, I was a router. I was connected to multiple devices. Let's say I don't want to send it to everyone connected to me, but I do want to send it to everyone on this particular network. And this network happens to be that 199.87.20 network. So this is my network address, /24. That means the first 3 octets are my network. The last one is the host. That would be the unique one. Now, if I want to send to all devices on that specific network, I don't use 255.255.255.255. That would be sending it to all 4 networks connected around me. I do want to send it to a whole bunch of different devices, all devices, but on that specific network. That is called a directed broadcast, directed to a particular network. So a directed broadcast would not go to all my networks. It would just go to the devices on a specific network. In my case, this address that I had. And that address would be represented by using the network address that I want to broadcast it to. So 199, let's say 87.20. And the host address, you put 255. Basically, in the host address, all the bits are 1111, 1111. So when your host portion is all ones, it is a reserved address that you cannot use for any device on that network. This is reserved for what? A directed broadcast. So if somebody wants to send traffic to all devices on a particular network, it will do what is known as a directed broadcast. So that would be the host portion turning to all ones. So every network will have its own directed broadcast address that will be reserved from that range of addresses that you can assign to hosts. So that address cannot be used. Okay, so that's a one-to-all type of communication. One-to-all, again, depends on the place that you're sending it to. So in one-to-all, what are the 2 options? Let me erase this first and then I'll type it out for you. One-to-all represents 2 things. Number 1, it represents what? All network broadcast. which is all the networks that are connected to me. I want to send it to all the hosts on those networks, all my networks. That is this address. And if I want to do a directed broadcast, which would be sent to all the hosts on a specific network, directed broadcast. So for that, I would need to use a specific broadcast address for that particular network. So every network would have one address reserved as the broadcast address. So in my example I was giving out was 255 because /24, this is the network portion. The host portion, if it's all ones, 255 would be all ones, represents the broadcast address for that particular network. Good so far, guys? Hopefully you guys are understanding it. These are the two common type of communications that you have. There is a third type that is also used on your networks. This type of address is called a multicast. So we looked at unicast, we looked at broadcast. There's a third type, not as common as the other ones, but it's there. It's called a multicast. This is where I have, let's say, 5 devices on a network. I have a transmitting device over here. Now the transmitting device sends a video stream that I only want to send it to parties that are interested in that transmission. So they acquire the client application for it. So this one wants it and this one wants it. The other guys don't want the communication that is being sent by this guy, or let's put it on 3 devices. So 3 out of the 5 devices want to listen to that communication, the other 2 don't. If I do a one-on-one type of transmission, it's going to go directly from the blue to the reds. But I would need to send 3 packets, one with the destination of the first device, the second transmission for the second device, third transmission for the third device. So rather than doing that, and I can send it as a broadcast, but that would mean that all the different devices, including these 2 devices, will need to listen to it, which might not be suitable because they're getting overwhelmed with unnecessary data that they're not concerned with. So what they did was they allowed you the ability, if an application wants to do this group communication, to get a group address. The group address would be assigned to the application. The application, as soon as you launch it, would assign it to the PC as well. So the group application, an example of this group address is something like this, 225, let's say 50.1.5, for example. This is an example of a group address or a multicast address. So what you would do is you would build the client application in such a way that it listens to the address that the server is sending. The server would be configured to transmit on that multicast address for that particular application. So he would send the packet to this group address. It will be sent to only the devices that are answering to this address, and who are answering to the addresses, to that specific address, is the ones that are using that client application. The client application, as soon as it launches, it tells my PC, hey, listen, I want you to process any packet that's coming in for 225.50.1.5. So it's not a network-based address, it's a host-based address which belongs to a group. This is a one-to-many communication. See, we did one-to-all, that means to all the different devices. In a broadcast, this is known as a one-to-many communication. And it uses a special address for it. It's called the multicast address, and this type of communication that is going from one to many is called a multicast application. So to recap, you have one-to-one, which is the most common one, one-to-all when I want to send traffic to everyone, and one-to-many, which is to a group address. So anybody that's part of a group will get it. All right, those are the 3 type of communications and 3 type of addresses that you're going to have. And that is what this is all about. So unicast, the most common type of IP address is the unicast address. Again, it will have a single receiver. The unicast address is associated with a single device or a host, which is the most common type of communication that you have. Broadcast, we talked about it, that you can send an all network broadcast, which is sent to whom? To everyone that's connected to me. Or you can send it to a directed broadcast using a directed broadcast, which would be sent to all devices on that network. So every network would have an address that would be reserved as the broadcast address. So when I want to communicate to all the different devices on that particular network, I'm going to send it to that address. And that broadcast address is going to be an address on that particular network where all the host bits are 1. When you see all the host bits as 1, that is the directed broadcast address for that particular network. And the third one, which is not as common, is called the multicast address. It's a special type of address that is dedicated for this one-to-many type of communication. And this address range starts from, when you look at the IP address, if you see a number between 224 in the first octet to 239, you need to recognize this as a multicast address. This is only being used when you want to do a one-to-many transmission. Very specific usages for it. All right, we'll take a look at a little bit more detailed look at it at a later stage. So this is a one-to-many transmission. So again, one-to-one, one-to-all, all meaning all networks or host on a network, which is the directed broadcast. All right, and then this was one-to-many, specific not to a network but to an application. So you need to have an application that is dedicated for doing multicast type of communication. Very specific applications do that. All right, so with that in mind, let's take a look at the review questions. It should bring up the things that we have discussed in this particular video. You should be able to answer these questions. Let's do this together. What is the size of an IPv4 address? It's made up of 4 octets, 8 bits each. So 4 times 8. 8 is the number of bits in an octet, which is 32 bits. Convert an IPv4 address 200.50.140.10 into its binary equivalent. How would I do it? Again, I'll put my magic table over here. And now, if I want to write 200, how would I write it? I would have a 128 and a 64 in it. That would give me 192. And 192 plus 8 would give me my 200. So the rest of the bits will be zeros. That's one way of doing it. So I would write it over here as 1100 1000. That is your 200. Now the next one is 50. So how would I write 50? Obviously I cannot use these, so 00 for this one. 32 plus 16 is 48. That leaves me with 2. So this would be the number. So I'm turning 2 on, 16 on, and 32 on. So it would be 00 11 0010. All right. The third one is 140. Let's do the same thing over here again. 140 would have 128. Cannot have this, cannot have this, cannot have this, because it puts me over 140. 128 plus 8 is 36, plus 4 is 140. So the rest is 0. So it would be 1000 1100. The last one is 10. Small numbers are easy to do because 10 is 8 and 2. The rest will be all zeros. So it'd be 0000 1010. Good. Hope you guys understand that. Now with that, let's go to the next one, which is converting binary IPv4 addresses into its decimal equivalent. So let's do this one first. Again, using the same table, the magic table as I call it. 1101 0010 is what I would do. I would write it over there and then add the bit values that are turned to 1. So 128 plus 64 is 192. 192 plus 16 is 208, and 2 is 210. The next one, again, I would write it in my table. 1001, and then I have 1011, right? This one over here, 1001, 1011. So it's 128 plus 16, which is 144. 144 plus 8 is 152. 154, 155. Okay, now bringing the third one in, which is going to be 0011, 0011, and then I have 1001. So that would be 32 plus 16, which is 48, 56, and 57. That knocks this one out. And the last one now, which is 1001. Oops, it's got an extra digit, so I'll get rid of that. 1010. That would give me 144, 152, 156. Let me see. 155 was. Okay, let's do it again. 150, 152, 154, sorry. Yep, 154. All right, let me fix this real quick for you guys, because you're going to get the slide as well. So this one would become this. That's the 154. All right, the third one, third answer over here now. Third one we've done. Fourth now. What type of address is used to send traffic to a group of addresses? That's your multicast address. Multicast is that one-to-many communication. What is the most common application on the internet? Most common application in the sense of multicast, unicast, or broadcast, as I told you. Unicast. What is the type of communication that is used to send traffic to all devices on a network? It's a directed broadcast. The reason it's a directed broadcast, not an all network broadcast, because all devices on a network. So if it had said all networks, it would have been 255, 255, 255, 255, which is known as the all network broadcast. All right. So that's the other takeaway that I want from you guys from this particular video. So again, the key components that I want you guys to be extremely comfortable with after this video. And if you're not, take a look at the video again until you get a hang of it. Number one, the conversion, the binary system, binary to decimal conversion, both ways. That's the first takeaway. Number two, the concept of the IP address and the corresponding subnet mask. The subnet mask is the one that tells the device which part of the address is the network portion and which part of the address is the host portion. That's the job of the subnet mask. So anytime you put an address on a particular device, you're also going to put a corresponding subnet mask with it. So network address and the host address is done by looking at the subnet mask. All right. So that's the other thing that I want you guys to get, the different formats of the subnet mask. You can write the subnet mask as 255, 255, 2550. I'll show you other masks as we go through it. This is your first iteration through the subnet mask, so I'm keeping it simple. 255, 255, 2550, which basically says the first 24 bits are my network portion. The other way of writing it is /24, basically saying the first 24 bits are my network portion. 0 represents the host portion. That's the third takeaway. And the fourth one is the type of addresses. What are the type of addresses that you guys have that we discussed? Unicast, broadcast, and the group address, which is called multicast. Hope you guys enjoyed it. This is a video that I would recommend that you watch it at least 2 times to get a full hang of the 4 topics that I listed on this page. Hopefully you enjoyed it, guys. See you in the next video.